Hello, hello, hello. All right. Let's make sure everything's working. Okay. So I want you to meet Jake. Jake writes bad code. But I don't blame Jake. It's not really his fault. You see, Jake, he was a tester. And his manager wanted to start test automation at the company. And so his manager tapped him to build this new initiative. Now, Jake, he's not a programmer by trade. He doesn't have much experience with this. But he was a good sport. Jake went out and he looked at some of the tutorials online, some from leading experts showing how to get started with Selenium. And Jake, he followed very closely, he studied the patterns, and he was able to implement those patterns. He even got his tests running. Jake was so excited about this. And so Jake continued to develop more and more tests using the same pattern. However, this was problematic because you see, those tutorials by the leading experts, they're well-intentioned, but they're only supposed to get you started. They kind of throw everything together in one big lump sum and remove a lot of the architectural complexities because, quite frankly, Jake's not ready for that level. So, little did Jake know there was more to this. And so as his tests were running, they began to fail. They became flaky. The team started losing trust in them. And they were shelved. The manager said, let's just put this on the back burner. Perhaps you are Jake. Perhaps you want to know how to better create your test automation. Or maybe you're Sue, who was hired in to revive the test automation strategy. And so now you've inherited Jake's code and you have to clean it up. Or maybe you're someone else. You totally have your act together. Your code is crystal clear. But you've done so well that now they want to expand this across the whole company. So now you have to bring on board a whole bunch of other automation engineers. Some are going to be more junior than you are. Hopefully, no matter which category you fit in, you'll get something out of today's talk. What we're going to do is we're going to actually look at Jake's code base, and we are going to refactor it today, live, right here. And we're going to sniff out the code smells. So what is a code smell? Well, it's where your code is not wrong. Remember, Jake's code, it ran. However, it violated some fundamental design principles such that it makes it difficult to maintain this code. And it's really easy to introduce things that could potentially be bugs. Okay, so let's look at the application under test that Jake was responsible for testing. It's a single page application, and it's a couple of books, 8 books, about test automation. Now, these books can be filtered down by title or by author. You can put in a full title or a partial. For example, if I put in Java, I see the 3 books that have Java in the title. If I put in Lisa, I see the book that's authored by Lisa Crispin. So this was Jake's application and test data. So let's look at Jake's code base. So we're going to look at 2 tests here. One that searches for the title, one that searches for the author. So if we look at this test, we see that Jake has some code to set up WebDriver, to launch the application. He specifies the title that he wants to look for. He then clears the search bar, make sure it's empty. He has a sleep in here because there's a slight delay. Let me show you. If we clear that, slight delay there. Same with searching. So you put a little sleep to be able to handle that. And then he sends the title to the search bar. And then he has some logic here to see if the book that he's looking for is actually visible or not. So he gets all of the visible books on the page, loops through to see if his title exists or not. If it does, the test passes. If not, it fails. And then he closes WebDriver. Now let's look at the author test. Again, he is setting up Chrome driver, launching the app, specifying the title, clearing the search bar, searching this time for the author, Lisa Crispin, and then looping through to see if the book is among those that's visible, and then closes WebDriver. So let's just run this. Make sure that Jake's tests work before we even get started with anything more. Okay, super fast, but we got some green here. Great. Okay, now we are going to go through several code smells. I've even created cute little poems to help you remember these smells. Now, if you're anything like me, you're going to be a little anxious because you'll see all of these filthy smells and you'll want to clean them up all at once. Please be patient. We're going to go one by one and clean the smells up because it's really important to iterate through this and not try to do too many things at one time, else we can confuse ourselves and make more trouble than it's worth. We might even introduce new code smells as we're cleaning one up, but I promise you by the end, everything will be clean. Deal? All right, let's do it. So the first smell is long class. The purpose of the class is multifold. To find anything, you must scroll and scroll. Why might this be problematic to have a class with a bunch of lines of code in it? Well, usually it indicates that there's no single responsibility there. The class is probably doing more than it should be doing, right? I once worked on a project, I kid you not, thousands of lines of code, and it was very, very difficult to find things in this class. And so sometimes you just gave up on looking or trying to determine if it's exactly what you needed, so you just reintroduced the thing and named it something else. And it makes it really difficult to maintain, so you don't know logically which of these methods kind of go together, so it's really difficult. So to clean up the long class smell, what we're going to do is separate concerns. So let's go back to Jake's code base. He has a lot going on in this class. Jake is doing the navigation, and he's also doing the testing. In test automation, we commonly separate these concerns into two main areas, the framework and the test area. The framework area is what handles all of the navigation and the logic and state of the browser, whereas the test should solely be focused on the test, okay? So what we're going to do is we are going to make a new class in the framework, and it's going to follow the page object model design pattern. We'll call this search page. So this is going to represent that one page. And we're going to take out all of this logic and move it to that class. So I'm making a new method in here called search. And you'll need to pass in the title. And we'll just paste this in here. All right. So we see that there's some errors with the driver, so let's handle that by making a global driver and a constructor. Okay. And this needs to return a Boolean, so we'll just say return if the book is visible after doing the searching. And in the test, what we'll do is make a call to that as opposed to having it all in here. So we'll make a new search page. Oh, I need to put this in a package. So let's do that really quickly. I need some music in the background. Okay. So search page, and we'll say pass it our driver, and then we can do the search. Okay. And so we got rid of a lot of code in there, and we can do this same thing in this one. Let's just delete all of this. Make sure that we are searching for Lisa this time. Cool. And get rid of all of this duplicate stuff. All right. Cool. So we've separated that out. This class is a lot shorter now. That's one code smell down. The next smell is the long method. This guy does it all, but it makes it hard to know when to call. So why is this problematic? Well, again, there's probably no single responsibility. You have a method that's trying to do all the things. And it's confusing for callers when that happens, right? Do I call this and it does this one thing, but it's going to do all this extra stuff as well? I don't really need it to do all of that. Usually when you have a really long method, you start adding a whole bunch of parameters as well that are optional in some cases. So it gets really nasty, okay? Difficult to read, difficult to understand. And we've introduced a problem. So as we separated that search method, they looked, in each of the tests, they looked similar, but there were some slight differences. If we look at this code for the author, for example, let's say we are searching for Lisa Crispin. So we search for Lisa Crispin. All of this is fine. However, when we go to look for the books that are visible, we are looking to see if the title we passed in equals the actual book title. Well, Lisa Crispin's not a book title. Could be, she's dope. But it's the author name. So when you move things to a higher level, what we've done is kind of extracted this out. When you extract to a higher level, you have to make it a little bit more generic so that it works in multiple cases. So to solve this smell, we're going to split the methods. So let's look at this search method again. We look in here, it's doing clear, that's one responsibility. It's searching, that's another responsibility. And then it's checking to see if the book is there. That's 3 different responsibilities all occurring in this one method. So what we're going to do is split this into 3 separate methods so that each one has its own responsibility. So we'll make a clear one. We'll take this out and just make the call to clear and move this here. And we can leave the search logic, but all of this stuff that's talking about is the book there, we'll remove. And so search really shouldn't give me a Boolean value. We'll make this void. and make a new method that says, is book visible? And this can take a title, and we just slap that there. And I'm going to change this from title, because we can search by title or author. So just to be very clear on intent, we'll make that like that. And so in our test, we need to go back, and we need to also make a call to is book visible. And same here. All right, cool. What other smells can we sniff out? Duplicate code. When you find yourself coding in haste, it's very tempting to copy and paste. So what problems might this cause? Well, any change that's needed, you have to do this in multiple spots, right? So you find yourself looking through the code base, where else did I put this logic? And you're kind of changing it. What if you tweaked it just a little bit in one place? Then now you've goofed up by doing this. It's just terrible. It can lead to other code smells as well, such as the long method in long class. So how do we clean this? Well, we just remove the duplication. So let's look in our framework and see where there's some dupes. So setting up the browser, launching the app, this is duplicated in both, as well as closing the browser. So we can move these into methods that are going to run before and after the class. So we'll do a before class to launch the app. And then we can move this stuff out of here and inside of there. Ooh, method is looking cleaner already. And same here, take this out. And then let's do the one that's after the class. And we can move this out as well. Oh, I'm getting excited. Okay, now we see a little problem with the driver. That's because it's declared inside of this method. So let's move this to a global scope so that everyone can have access, and then we'll just initialize it there. All right, nice. Now let's look, well, here, I'm looking at this. Oh, this search page. Yes, this is duplicated as well. So let's move this out. And we'll instantiate that in our setup thingy. So now I can move some more code out of here. Ooh. Okay. Aha. Okay, so if I look at this, this is still a little bit redundant, right? We see a little pattern here. I could abstract this a little bit more as well, but there's also a thing as too dry. Dry is don't repeat yourself. And so you start abstracting out all of the things, and then it becomes a little bit unreadable. Let me show you what I mean. So I can do something like, oh, we're going to test the search and give us the query and give us the title. And I can then move this here, right? And say query title. And then I could just call this method. I can make this like a really like a one-liner. Maybe two. I could do like test search and then do that. Now that you're thinking, oh wow, nice short method. We really shortened that thing. But when you look at this later, not right now, you come in and you try to read this, you say, okay, what am I doing? I test search. Now you have to go to this method and then read what that method is doing. In my opinion, this is a little bit of an overkill. Sometimes you can make some trade-offs for readability. So this wasn't that bad before, you know. So I'm going to change that back. Now, if you did that, that's fine. It's not illegal. I wouldn't even consider it a smell. It's a matter of preference at this point. I like to come here. I can clearly see what's going on. I'm going to search. I'm going to see if the book is visible. Okay? Let's see if we can get rid of any redundancy in our framework class. Yes, we have this search bar that's repeated across. So in test automation, it's really good practice to move your locators into one central spot as opposed to repeating them, because like we said, if this changes, now I have to go find all cases of this and change it. So let's take this out. And we'll make a by object called search bar. And now we can just use this. So if this ID changes one spot, I don't have to go looking all around the code for it. All right? And this thread sleep stuff is a little redundant too, but we'll clean that up with another smell. All right, moving along. The flaky locator strategy. Ah, yes. We should all be familiar with this, yes? At this moment, your locators work fine, but can they stand the test of time? If you are someone who goes to Chrome, go to the DevTools, and you say, hey, Chrome, what's the XPath for this? And you do a copy XPath, I beg of you to stop doing this. The reason why is Chrome is not doing you any favors. Chrome has no idea that you are using this, storing it into some script that you expect to still work a month from now or a year from now. Chrome is giving you the XPath as it exists today. And usually that's filled with things like an ancestry tree and indexes, when you probably can get something that's much more reliable. Okay? So this is the #1 cause of flaky tests. Your locators are fragile and they then are unreliable. So we're going to stabilize the locators in Jake's code. So we have this one, the ID. That's fine, that's great. We have this other one, however, that's an XPath that's looking for something. I don't even know what. So let's go to our app and see what this could be. Okay, so this is finding one particular book, the Java for Testers. Aha, so this was in the very first test. So it looks like we had some hard-coded identifiers in both of those tests. But remember, when we abstract to a higher level, we need to make this more generic so that it works in all cases. So we can't look for just a specific book, right? If we look back at this code, it is trying to find, looks like all of the visible books and loop through them. So we need a query that's going to give us all of the visible books. So let's first make some not visible so we can see what we're working with. So if I look at this, it looks like I have all of these books as LIs. Even the ones that are not visible are still here in the DOM. And so I don't think I can use the IDs here. I need to look for other things. So I move on to the class. Some of these have UI, LI has thumb. All of them have this. Some have a hidden one. I see a first child. This hidden one looks promising, right? So if I'm looking for all of the visible books, then I could probably do something like find me all of the LIs that do not contain the class UI screen hidden. And I have 3 that have come back. Haha, 3 visible books. Let's make sure it's the ones we want. Yep, perfect. So this should be our locator. This one is much more reliable than that. So I'm not going to paste it into that method. I'm going to make another one here. So we'll call this visible books. And this is a CSS selector. So we'll do this, and then we can change this to that. Nice. What other smells? Indecent exposure. Too many see you. Your scope is too wide. All who should know you are the ones inside. So this is where we have methods or fields that everyone can access. Why might this be problematic? Well, for one, it violates encapsulation, which says that your fields should be, your data should be private, and you should have public methods to allow for the behavior of that. And then also, we just cleaned this up by splitting out the framework from the test, by allowing direct access to things like web locators. We are almost encouraging our test class to make use of those things. And if we start bringing that back to the test layer, then we're reintroducing that problem with the responsibility, okay? So what we're going to do is go in here. This one is really simple. You just make all of your fields private or protected if you were doing inheritance. And look through all of your methods. So I typically make all the behavioral ones public, but if I were to have a method that was maybe a util method for this class that takes a web element or returns a web element, I make those private so that the test class doesn't get into using them. And then here, we'll just make these private as well. If we would have kept that little method to make these tests extra dry, that would have been something that would have been private. All right. And why is this barking at me? Did I mess something up? What happened to my locator? All right. Cool. So what other smells? Inefficient waits. The speed of machine is faster than man, so you slow it down any way you can. And how do people typically do this? With the sleep. No, please, no. Why is this problematic? Well, it slows down your runtime. Well, that's what I wanted to do, Angie. But you have different environments. Let's say you want to run this across more than just your local machine, right? And so you start running this in different places. Well, some of your machines might be a little bit slower. And so what do? You find yourself chasing your tail. So it took, looks like it takes about 1 second for this to occur. So I put a 1 second sleep. If I run it somewhere else or I run it tomorrow, even on the same machine, it might take 1.2 seconds. Well, now the test fails. So you increase it to 2, right? And then on some other really slow machine, it takes 2.2 seconds. Well, now you do what? I'll just make it 5. If it fails at 5, it needs to fail, right? The problem with this is the sleep is going to stay sleeping for 5 whole seconds, when maybe all you need is 1.8 seconds. And so that's quite a lot of time to waste. Might not be a big deal in one test, but when you start having hundreds of these, that starts adding up really quickly. So we can wait intelligently. WebDriver actually has this really cool method called WebDriver wait that lets you wait for a condition. So I can say, here, take my driver, and you give it a timeout, different than a hard-coded. You say wait up until 5 seconds. If you can find it before then carry on. So this has a wait until, and you can pass it an expected condition. So for clear, what condition are we waiting for exactly? Well, if we look at our app, we are waiting for all of the books to appear. Now that's a hard thing to express, especially if you don't want to tie yourself to the test data. So I don't want to say like wait for 8 books or something. What if I add 2 more? So really I can say something like wait for none of the books to be hidden anymore. So I can even do that kind of thing in here. I'm going to make a hidden books selector. And this will simply take out this whole not clause. That should give us the hidden books. I can say wait until the number of hidden books is 0. All right. And then let's get rid of this sleep as well. For search, I was going to copy and paste that, and that is a sign, right? If I do that, I'm probably introducing some redundancy. So let's move that. Oops. And we'll move this to the constructor, and then we can get rid of this. Ooh, it's getting shorter and shorter. Okay, so now we want to wait until maybe the presence of hidden books. We want to wait until something goes hidden. All right? So cool. That is introducing the wait, getting rid of the sleeps. Let's see what else. The last smell. Multiple points of failure. The framework's job is to force state, not to determine a test's fate. So again, with the separation of concerns, right? You're going to violate that single responsibility once your framework starts trying to determine if a test has passed or failed. Your framework should be neutral. It should give you information about your application. This exists, this doesn't, this is the text, things like that. And then your test's job should be to determine what that means. The reason is you want your framework to be reusable. If it starts failing tests in certain conditions, then what if you want a test that is a negative test case? Now you can't use that same method, okay? So let's clean this up by increasing the flexibility. What we're going to do is just simply remove all of this assertion code. Just tell us if it's there or not. Let me copy this. So if you find the book, just return true. I don't need you doing anything extra. And if you don't find the book, return false. And we can remove this as well. And then just go back to our test, and this is where our assertion should go. So we're going to assert and just move this to here. Oops. And same in the next one. And voila, we're done. So, nice short methods here. Our classes are short. That's your error. And let's go ahead and just run this to make sure it all still works. And we should be done. Fingers crossed, everyone. Hey, it's green. So it all still works. So we've helped Jake out. We've cleaned up his code. Hopefully these have been helpful for you. I'll put the slides online if you want to review the little poems, but don't steal my stuff, all right? Go ahead and credit me, all right? Thank you so much. Again, I'm Angie Jones. Here's my information if you want to find me. Thank you.